Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link in the chat for our on-demand content. And if you have not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Now let's get started.
Hello, welcome to the AI 900 certification program, Artificial Intelligence Fundamentals by Human in Azure AI. I am Jacqueline Ramos and I am part of Human in Azure AI leadership team. This program was created by the Homemakers Code and the Tech Human community in collaboration with Microsoft experts. It is open to the entire community to learn the fundamentals of artificial intelligence, chatbots, machine learning, and the generative AI. The program includes 8 live classes, completely free in English, and required proof of participation at the end of the program. Requirements for proof of attendance. To receive your certificate, follow 2 steps. First, attend the live classes or watch the recordings between May 60 and 29. Second, complete the keynote texts until May 31. A week after the second class, you have access to a quiz to reinforce what you have learned. When did you earn the AI 900 certification? There are additional 30 steps. Complete the Cloud Skills Challenge before May 31. You have access to a free Microsoft Learning Path with hands-on AI labs. The 100 most committed students, you received a voucher for the AI 900 certification free of charge. Good luck with your studies. See you soon.
Hello, everybody. Thank you for joining us today. So let's start the session. So we are going to talk today about generative AI and generative artificial intelligence. Today with me, so I'm Joanna Machado. I'm a principal PM for the Applied AI Engineering team in the Azure AI. And with me is going to be Sanely Rodriguez, who is a senior consultant in the app development team. So both of us are going to guide you today during this session. We have a full panel of moderators. So we have Bobby Russell, Gabriela Cunha, and Jacqueline Ramos that are going to answer questions in the chat. Having said that, so continue, keep learning. So here are some links and a barcode that you can scan to learn and follow the path, the learning path for this certification using aks.ms, Woman in Azure AI, start here. This is our agenda. So today we're going to talk about 3 main topics. One is going to be about generative AI basics. The second one is going to be how to get started with Azure AI Foundry. And if you have the opportunity to participate in Microsoft Build last week, you will learn more about this. You can always go online to the on-demand content if you want to learn more. And the third topic is going to be about exploring responsible generative AI, artificial intelligence. So let's kick off and talk about generative AI basics. When we talk about artificial intelligence, this is not a new subject for the market. So pretty much artificial intelligence has been around since 1956. So in the field of computer engineering, the people have been, researchers have been always looking at how we can make the computers learn and learn in a similar pace as the brain is learning. So after that, all this computing learning in the 1997, all the concept about how those computer learns, neuro systems, and all the machine learning, which is a subset of what artificial intelligence is, come into a place. So after that, thinking on, well, do we have the right type of computers or to process large amount of data? A lot of innovation happened between the 1997 and the 2017. So now the concept about deep learning not only providing a statistical and mathematical the algorithms to the computer to learn, so allowing the computer to learn by similarities of content, or also create some sort of inference from a data or an information that the computer is receiving, right? So that has been possible since machine learning in 1997, and now is going even more deeper with deep learning, right? Which is pretty much a technique from machine learning that allow neural networks to, process data and make some decisions, take some decisions, right? The next one, so what we're going to talk more about is about generative AI. So generative AI is part of all this large period of learning and developing on artificial intelligence. And generative AI can create new content, even in text or visually from existing information. So we're going to talk deeper today about what is generative AI. So when we talk about some examples, okay, so now the computers, I got it, the computers learn, the process of the research on artificial intelligence has been evolving from those, neural system into something that is more closer to individuals and people common like us, right? So that's the power of generative AI. Think on generative AI that you can interact with the foundational models, which are big models that have been trained with a lot of data. In the case of Azure, OpenAI has been trained with data from the internet since until 2021. So imagine all that data, right? So how you can easily interact, and users can easily interact with that information. So number one is using a prompt. So you can use text, and then using text, for example, so we can ask the computer, can you write a slogan for an ice cream parlor? And the response, is a slogan for that one, right? And it's also the interaction happening in natural languages. You don't need to be an expert coding, so you can ask your own language the way how you daily speak on connecting with that, right? So the other way to do it is using code. Okay, what if, what's the technology that Microsoft use, for example, in GitHub Copilot, right? So now with GitHub Copilot, you can work on that Copilot, and that Copilot can write code for you if you are a developer. Well, the way how to do is behind of that is a natural language model that is interacting using code. So the prompt in this case, in case of instead of asking the model for a text, you can ask, hey, can you create a SQL query and find, under the customer client's data, the customer names or customer that is in Texas, which name is Jane, right? And if you see the response in the green color in the slide, is showing a query in SQL when the code is going to select from a customer table in a specific state using the field state and also the first name Jane. Right? So it's a second and a different way to interact, an additional way to interact with those LLMs. The third one is on images, right? Now models are multimodal, right? Generative AI is multimodal. The O series of GPT is multimodal. So now you can interact using images too, right? So not only text, you can add, well, can you create an image? Like, for example, in the promise as a Siamese cat, that is white. So, and see how accurate the model is able to read a white cat, not a cat with another color, right? Similarly, as I was mentioning, with the multimodals, you can use an image, and then the model can respond using text or using another image. And now with the newest models of Azure OpenAI, you can use also audio and use your speech, your own voice to interact with those models. In the slide, you see a 4 column that is the chat, right? So everything you can make it available to the users through a chat interface. That's what ChatGPT does, right? And again, the way how you can prompt the model, depending on the model that you choose to interact. For Azure OpenAI, you can use text, code, images, audio, and speech, even though they are not in the columns in the slide. But you need to be aware that those ways of interacting with the model are also available now, right? Let's go deep about, okay, This is how these models interact, but what is behind that? In a very, very simple way to bring this example, think about these big, large language models that they need to understand using a coder is the box in number two. Sorry, because I have some text in Spanish, but pretty much the number two is a coder, so needs to code something that is understandable by the computer, and after doing some analysis, return through a decoder, the answer to the prompt, right? So let's follow the chart, right? In the square number one, you see that there is a need for text, a lot of data to train the model, right? And that model going to that information going to the coder, right? That is the number two. For token processing, token is a very important concept for the generative AI models because it's the way how the model divide the information in pieces, right? And small pieces. And it's also how the models, when you use the models, are charged, right? But number of tokens used, right? So if you are building a generative AI model, you want to understand how many tokens are in my prompt or in the way that I ask the model. If you see in the previous slide, we have 4 different prompts, right? You want to make that effective enough to optimize the number of tokens, but also it couldn't be short and too short because then if the information is not deep, and the instructions are not clear in the prompt, so the answer that you can get from the model could be too generic. So it's the good balance between the number of tokens and how you build the prompt is really key, right? In fact, it's now becoming a new way of work, right? On tuning or working with those models, how important is to have that prompt engineering in place, right? So then the coder look into, well, that receive a bunch of information divided into a dog, into a cat, into a puppy, and into a skateboard, right? This is an example, but look into the third column in the chart. So how the model vectorize that information, that's what we call embeddings, right? So how the model don't really know what is a dog, but identify the attributes of that dog, right? And transform that into a vector. In this case, in the example, is the 1032. So every time that in the interaction with the model we mention a dog, for the model it's going to be a representation of a vector 1032, right? So that's the way how it looks also into similarities, right, between the vectors. And if you see in the chart, in the small cube in the bottom of the slide, so you see how the representation of each is. So the dog is a 1032, but it's also identified like a vector number 4, right? And when you compare with a cat, that is this blue arrow in the slide. So it's a different vector, 1032, and is identified like the vector number 8, right? And then it's how that information go into the decoder and then transform that into a text, right? So for example, in this prompt, if you say, when my dog was, right? So understand that is a dog and associate, look into similarity of vectors to identify the high probability of the best answer that the model should say, right? In this case, the decoder go into that, and if you see in the vector number 4 and number 9, that are the dog and the puppy, are in the same direction and the same dimension in the three-dimensional representation, right? So that's how the more common or the more similar uh, word to use is puppy, right? So then the output is a puppy, right? So it's really important here to understand how it works, the concept of tokens, the concept of prompt, and how those embeddings work into the language models if you are preparing for your exam. More information we're going to share right now in the next slide, right? So talking about tokens. What is a token? So a token is not necessarily a word, but it's a number of letters. Usually, a good rule of thumb is about 5 letters, but not necessarily is that number of letters. But let's see in this example, right? So there are tools in internet, so you can analyze the number of tokens that you're using, and also if you're also using Azure AI Foundry, when you build your application, you're going to be able to identify how many tokens I will need to interact with the model, right? So in your use case. But let's look into the tokens example. So this is a sentence. I hear a dog bark loudly at a cat, right? And then the model assign, this is an example. So for the word I is a token number 1, here is a token number 2, A is token number 3. So notice like in the sentence, the word A is included more than one time in the sentence. So the model don't need to retoken that word or that letter. So it's able to identify that I hear a dog, the A word assigned, the model assigned the token number 3 is the same that you use when you look here into add a cat, right? It's the same word, is the same token, right? So then the sentence can now be represented with tokens. Tokens 1, 2, 3, 4, 5, 6, 7, 3, 8, right? Because the letter A is repeated. And if similarly, if I want to build another sentence or the model needs to process another token for the sentence I hear a cat, so now could be represented as the vector 1, 2, 3, 8. Right? So that's a good key concept to understand the tokens and the number of tokens that you're using in your model. Also, the quality of the prompt that you are using to interact with the model. Right? What else about tokens? So let's continue talking here about insertions, right? So I explained it a little bit in the previous slide. So how vectors are represented, right? So any interaction with the model is a prompt that is questioning or providing an interaction with the model or a response in a token or in a prompt. So it's going to be represented here. So that's how internally the system is able to understand, well, divine token, what is the request from the user, then look into the data that has been used to train the model, what is similar, and how the vectors has been represented. Is already a vector that I have or already a word that I have been trained, and if not, so looks into similarity of on the word, right? Also, you will learn today that you can also customize and train your model, right? So hey, what happened if the data, if I'm using Azure OpenAI and the data from internet is not necessarily represented my industry, my specific sector, my specific use case. I'm working with machines or printers, right? And then not necessarily the information that I want the model to retrieve is whatever they have on internet. I want they use my data because I have my own knowledge and I have my documentation. You can do that, training the model. And the way how it's done is through these insertions, right? So you can use vector or revectorize your data, adding more data to the decoder. The decoder is able to revectorize that and then look into the data. And there are some techniques like you can connect with your own data using services like Azure AI Search. You have been seeing this in the last session on the 22nd. And also you can use fine tuning, right? So you can do more deeper training to your model. But this is the logic how it works. Remember vectors, tokens, and prompt. And then how the models get the attention. Okay, I got so how the models receive the data, how the data is processed internally by the model. But what is the concept of attention, right? So it's a technique that used to identify the sequence of tokens, divide the sentence into tokens, and then compare and quantify, assigning weights, right? So which are the words or the content in that sentence or in the prompt that are more relevant for the model to look for those similarities, right? So this is an example. So the objective here, the first, the input token is I hear a dog, right? So the model represent that as a vector, as we previously see, and then assign more weight to the words heard and dog, right? To look for the next or to predict the next word that makes sense, right? And also, if you are using our copilots, a simple example here, if you're using Microsoft Word, when you start typing a sentence, how the Microsoft Word suggests the next logical word in your sentence is by doing this, right? Because decompose in tokens where you're typing, and by attention, assign more weight to a specific word in your sentence, right? So if we look into, let me post this chart. So if you see into the image in the right, so pretty much what it's doing is you see that I hear a dog, but don't know what's the forward that is going to be predict, then decompose that into assign a vector to each of the words, and then get back into the decoder and predict the next word that is bark. Right? So that's how in a cycle between the decoder and the coder create that cycle on interacting with all your prompts. Right? What else do we have? Well, how we can use those language models. So we learned that, okay, so we have a generative AI. Generative AI has been an evolution of artificial intelligence. Now understand more about the coder and the decoder and the easiness on interacting with the model because it's using your own language, right? So the models have been trained in different language and dialects, so it will be able to understand what you are saying, what you are typing, and any image, right? Remember in the way how you can interact with the model, we mentioned text, audio, images, and also your speech, right? So, okay, so now I hear that there are LLMs, large language models, and SLMs, right? Pretty much the difference is the number of parameters that each of those foundational model has been trained, right? And the number of parameters not necessarily means that they're going to be more effective for your use case or less effective for your use case. Think about when building your application now, how important it is to identify the right model and assign the right model to the right task, right? Also think about, well, number of tokens, right? And how experts the model is in my area. I give you the example about a company that is doing support for printers, right? So maybe it's good for that use case to have a specific to train the model with a specific data for that company, right? So the model, when predicting whatever the next word for customer support or the next word for the engineers that are fine-tuning things or fixing things, printers in the help desk can use, it's better to have their own data, right? Or their own information, or have a model that has been trained on a specific area, right? And you hear more and more with Azure OpenAI that we have two type of models, right? And not only Azure OpenAI, so all the LLMs we have available in Azure AI Foundry, all the more than 1,900 models now. So imagine the plethora of models that we have. Some have LLMs, large language models, and others are SLMs, right? The more common ones that you can find in Foundry are for SLM, our 5 model that has been trained with less parameters, but has been shown, better a good result for the academic, right? And has been trained using the data. And other, the more common one is also the Azure OpenAI. But now we have reasoning models too, right? So depending of the task, so I want to interact with the model, but I want the model to provide high computation, high analysis on on mathematics, right? Because the research or the use case requires that you can use those reasoning models too. But again, what is key here is about, well, models are going to come. What is what is the best model for the task that you have on hand or for the use case? And for the exam, for the I-900, you need to be aware that there are also LLMs and SLMs. More models are going to be launched, and have been launched very frequent since the launch of Azure OpenAI. But it's more about, hey, where is the place where I can find those? You can find those in Azure AI Foundry. I will show a short demo now. And then in Azure AI Foundry, pick the right model, right? Because then you need to understand the tokens, the implications on the efficiency, on how you ask the model to get the best response from the model, right? Let me move into, so here is more about the model catalog. So I have been mentioned about Azure OpenAI. So Azure OpenAI, you can find it in the catalog, in the Azure AI Foundry, and also in the Azure Machine Learning Studio, right? So in the session that I provide about document intelligence and Azure AI Search, I made some difference between what it was called the Azure AI Studio in the past, that is now Azure AI Foundry, right? You could find some reference in the learning content referring to the Azure AI Studio, but the Azure AI Studio is now the Azure AI Foundry. And then you can also get the information, models about the models in the catalog, right? So let me go there really quick. Azure.com, so you can get into Foundry. That's what I have been done here. And then And then in Foundry, you can see the model from Elon Musk model, and also introduce model router, right? So you can see in the model catalog. So if you want to be on top of the recent announcement, you can look here for all of them. You can browse them, which are the new models. As I mentioned, we have more than 1,900 models. And then another thing that is very relevant is we have, you can see when you click into the model, more detail about the model. Right? So when choosing, well, what's the right model for the right task, so you can explore here, well, what this model is about, what capabilities it has, your application, also to evaluate which is the right model for the right task, and be on top of, well, what model is available. We have more than 1,900 models, model from open source, SLMs, LLMs, so you can jump and start building your application. Okay, let me go back to the presentation really quick. And then you can build your tools are very common to use chat, and that's the interface that you see also in our copilots, right? So now in Microsoft, we are embedding all this technology from generative AI Foundry. So our own, I think that I already covered this about get started about Azure AI Foundry. Here is more information. You can sign in Azure AI, sorry, http.ai.azure.com. It's completely free. You can interact. If you are going to start testing and using a model, yes, you need your Azure subscription. And with your Azure subscription, you can start using the playground, check the models that are available, and start building your application. Right? When to use Azure AI Foundry? So you can use Azure AI Foundry when you need to create and manage an artificial intelligence or develop an application, explore available models, and also monitor and evaluate your application. Talking about your application, it's really important to think about responsible AI and how to deploy your application. And now it's time for my colleague, Sonali, to cover this topic.
Thank you, Joanna.
Sure.
Okay, awesome. So just like my coworker just mentioned, we're going to be covering implementing a responsible generative AI solution in Azure AI Foundry. Okay, so generative AI is one of the most powerful advances in technology ever, and this enables developers to build applications that consume machine learning models trained with a large volume of data from across the internet to generate new content that can be indistinguishable from content created by a human. But with such powerful capabilities, generative AI brings with it some dangers, and it requires data scientists, developers, and others involved in creating generative AI solutions to adopt a responsible approach that can identify, measure, and mitigate risks. So today we will be exploring a set of guidelines for responsible generative AI that has been defined by experts at Microsoft, and the guidelines for responsible generative AI build on Microsoft responsible AI standards to account for specific considerations related to generative AI models. So let's start with planning a responsible generative AI solution. So the Microsoft guidance for responsible generative AI is designed to be practical and actionable, and it defines a four-stage process to develop and implement a plan for responsible AI when using generative models. The four stages in the process are map potential harms that are relevant to your planned solution. Second is measure the presence of these harms in the outputs generated by your solution. Third is mitigate the harms at multiple layers in your solution to minimize their presence and impact and ensure that transparent communication about potential risks to users. And the fourth one is manage the solution responsibly by defining and following a deployment and operational readiness plan. So let's move on to mapping the potential harms. So the first stage in responsible generative AI process is to map the potential harms that could potentially affect your plant solution. There are four steps in this stage, as shown here in the diagram. We have first identify potential harms. So when you're building a generative AI solution like a chatbot, a content generator, or an assistant, it's very important to think about what could go wrong. And these risks or potential harms depend on a few things. It depends on what tools and models you're using. So, for example, you might be using GPT-4 or Azure OpenAI. How have you customized them? So, for example, are you training them with your own data, or are you adding specific instructions? So, some common risks include the AI might create offensive or discriminatory content, and it might generate false or misleading information. And it could also suggest or support illegal or unethical actions. So, to avoid these issues, you need to understand how your AI model behaves. And that means reading the documentation that comes with the tools that you're using. So, for example, Microsoft provides a transparency note for Azure OpenAI, and OpenAI offers a system card for GPT-4. All these explain what the model can and cannot do and where it might go wrong. So Microsoft also provides a responsible AI impact assessment guide, and this guide helps you think through possible harms and document them clearly so your team and your stakeholders can make informed decisions and build safer AI systems. So the second point over here is prioritizing the harms. So once you have identified the possible risk that your AI system might cause, the next step is to figure out which ones matter the most. So this is what we mean by prioritizing the harms. So to do this, you can ask yourself two questions for each of the risks. One is how likely is it to happen? And second, how bad would it be if this actually happened? So then you can focus first on the risks that are both likely and serious. So, for example, we can imagine that you're building a smart kitchen copilot that helps people cook. Two possible risks for this might be that it gives the wrong cooking time and someone eats undercooked food, or it gives a recipe for a poison if asked. In this scenario, both outcomes are bad, but the second one is clearly a lot more dangerous. But however, the first one might happen more often. So in this case, the development team needs to decide which one to fix first. And this decision can be a little tricky, and it most likely will involve consulting policy or legal experts in order to sufficiently prioritize your harms correctly. So the third step in this diagram is test and verify the presence of harms. So once you have figured out which risks are most important, the next step is to test your AI system to see if those risks actually happen and under what conditions are they happening. And this is where a method called red teaming comes in. So think about it like a stress test. A red team is a group of testers who try to, let's say, trick the AI into coding something that it shouldn't, like, for example, giving dangerous advice or generating offensive content. So, for example, if you're building the smart kitchen copilot that I mentioned before, the red team tester uh, might ask it for a recipe that includes raw chicken, and if it sees that it gives unsafe cooking times, um, it can also try to get it to describe how to make something harmful like a poison. So if the AI gives a bad response in any of these two scenarios, then obviously that is a red flag, and these results can help you understand how likely the harm is and what triggers it. Red teaming is commonly used in cybersecurity to find weaknesses in systems, and in generative AI, it helps you find and fix harmful behavior before real users ever get to use it. So this kind of testing is the key part of building AI that is not just smart, but is also safe and responsible. And we have a fourth point here, which is document and share details of harms. So when you have gathered all the evidence to support the presence of potential harms in your solution, then you have to document the details and share them with your stakeholders. The prioritized list of the harms should be always be maintained and added to if new harms are identified. So measuring the potential harms. So once you have identified and prioritized the risks that your AI system might cause, the next step is to measure how often those risks actually show up. And this helps you understand how serious the problem is and gives you a baseline to compare against as you continue improving your system. So a three-step process to do that. You can do one is creating test prompts. So think of questions or inputs that might trigger harmful responses. For example, if you're worried that the AI might give dangerous advice, then you can try asking it for something like, how can I make an undetectable poison using household items? After that, second point is run the prompts through your AI. So see what kind of responses it gives you. Does it answer the question? Does it refuse? Or does it give a vague or misleading response? And the third point is evaluating the results. So you can, for this one, you can use clear rules to label each of the responses. You might say that it's either harmful or not harmful, or use a scale like low, medium, or high risk. This would help you quantify the problem and track whether your changes are making things better. Also, another very important thing to consider is manual versus automated testing. So it's very important to start manually, test a small number of prompts by yourself to make sure your evaluation rules make sense. After you have that done, then you can start automating. So you can start using scripts or AI models to test lots of prompts quickly. So even if you have automated already, it's important to keep checking manually from time to time to make sure that your automated tests are still accurate. Let's move on to mitigating potential harms. So after defining a baseline and a way to measure the harmful output generated by the solution, you can take steps to mitigate the potential harms. And when appropriate, retest the modified system and compare harm levels against the baseline. Mitigation of potential harms in a generative AI solution involves a layer approach in which mitigation techniques can be applied at each of four layers that are shown in here. So we can start with the first layer, which is the model layer. This one consists of one or more generative AI models at the heart of your solution. So, for example, your solution may be built around a model such as GPT-4. Mitigations you can apply here at this model layer include choosing a model that fits your needs. So, if your task is simple, then a smaller model might be safer for you. Also, fine tune the model with your own data so it can give you more relevant and controlled responses. For the second, we have a second layer, we have the safety system. So the safety system layer includes a platform level configurations and capabilities that help mitigate the harm. So for example, Azure AI Foundry includes support for content filters that apply criteria to suppress prompts and responses based on classification of content into four severity levels, which is safe, low, medium, and high, and four categories of potential harm, which is hate, sexual violence, and self-harm. So if I have a little bit of time, I'll be showing up a demo on the content filters that Azure AI Foundry has. Um, Other safety system layer mitigations can include abuse detection algorithms to determine if the solution is being systematically abused. So, for example, through high volumes of automated requests from a bot, and then it can get alert notifications that enable a fast response to potential system abuse or harmful behavior. So for our third layer, we have the system message and grounding. This layer is about how you talk to the model. So what instructions and context are you giving it? Some techniques that you can apply here is use system messages to set rules for how the model should behave. You can add grounding data, so trusted information that helps the model give accurate answers. And also use RAG, which is RAG stands for Retrieval Augmented Generation. This will help you to pull in real time and reliable data when generating responses. For our fourth layer, we have user experience, and the user experience layer is the app or the interface that your users will be interacting with. And some of the best practices to follow here include limit what users can input to reduce risky prompts, validate both input and outputs, and be transparent. Let users know what the AI can and cannot do, and what risk might still exist when using your AI solution. So by applying all these safeguards at each of these layers, yeah, you can create a very strong multi-level defense that helps keep your AI system safe, ethical, and trustworthy. So let's move on to manage a responsible generative AI solution. So once you have identified all the risks, you have measured them and put safeguards in place, then you're almost ready to launch your generative AI solution. But before you do, there are a few important steps to make sure you release a safe, smooth, and responsible solution. So first, before launching, do a pre-release review. So make sure that your solution meets all the necessary rules and standards. And this includes reviews for legal, privacy, security, and accessibility. So for legal, you want to make sure that you're following the law. Privacy, you're protecting user data. Security, your system is safe from attacks. And accessibility, can people with disabilities use it? So these reviews can help you catch issues early and avoid obviously problems in the future. Um, Once you're in the launch phase, then you can plan for a safe rollout. So it's not you shouldn't release your AI to everyone all at once. Something that is recommended instead is start with a small group of users to test things out. Also have an incident response plan so you know what to do if something goes wrong, and create a rollback plan so you can undo changes if needed, and be ready to block harmful responses or shut down misuse quickly. Also important to give users a way to report problems. So if the AI says something inaccurate, offensive, or harmful, your users can provide feedback on it. After launch, very important to monitor and continue improving. So keep an eye on how your AI is performing, collect feedback from users, like I mentioned, track telemetry, so how your system is being used. This helps you to spot issues or areas for improvement, and make sure that all your data collection follows privacy laws and your company's policies. So see. Uh, Azure AI Foundry, also another content safety is using Azure AI Foundry because Microsoft provides tools to help you keep your AI safe. For example, using prompt shields, which helps detect risky user inputs, groundedness detection, which checks if the AI answers are based on trusted sources, and protected material detection, which is flags copyrighted content, and custom categories, which help you create your own filters for new or emerging risks. So all these tools help you maintain a responsible AI system, even if it goes live. I'm gonna jump in here, have a quick little demo. search. Uh, I don't see it switching on my, stop my screen share. Okay, so I mentioned Azure AI Foundry has content filters already. So I'm going to just provide a quick little demo here on how you can use those content filters. So if you go, the first thing obviously is to have your model already deployed. So in this case, I'm using 5.4. I already have it deployed, so I'm not going to go and create a whole new model. But if you need to see on the Azure AI Foundry portal, you just go under My Assets, Models plus Endpoints, Deploy a Model, and you can go to Deploy Base Model, and then you get a huge list of all the different models available to deploy. In this case, I already have mine deployed. For 5.4, um, right now, if I go to edit, it gives you the option of what type of, here on the bottom, you said content filter. Usually this will be set to default. So we're going to go ahead and just set it to default and test that out. So once you have set up your content filter to default, which that's how it will be created at the beginning, open play for your model called content. So for this, if I cut myself, so I'm going to ask the model that once it's done loading. And you'll see the differences once we use the default content filter, the type of answer that it gives you, as you see, is providing instructions of staying calm, stopping the bleeding, clean the wound, apply, straightforward answer because the content filter is set to default. But if we end up changing this content filter, which we can do by going to guardrails and controls, this is where you can create your own filter. You can set up the severity levels, just like mentioned. We have a filter created here. So we're just going to go ahead and check that one out. But it's very simple to create one. You just hit create. Then it gives you all the options to set up the level of severity that you want to use for violence, hate, sexual, and self-harm. So in order to test that same question and see if it would flag it as self-harm, this self-harm would have to be set up to the highest severity level. So I already have that set up. So I'm just going to go back to my model, and I can go back and edit the content filter and use that pre-created custom filter for the demo. I'm just going to apply it to the model. And I'm going to go ahead and ask the same question. And with the new content filter, this should be flagged. As you can see, now it got flagged because I set up the self-harm content filter to the highest, which ends up flagging this question as self-harm. Okay. Let's move on to presentation. Okay. So we have introduction to AI agent development. So what are AI agents? AI agents, I think we already mentioned a couple times, but they're smart software services that can combine generative AI models with contextual data and the ability to automate tasks based on user input and environmental factors that they perceive. So, for example, an organization might build an AI agent to help employees manage expenses or expense claims, and the agent might use a generative model combined with corporate expense policies documentation to answer employee questions about what expenses can be claimed and what limits apply. So additionally, the agent could use a programmatic function to automatically submit expense claims for regularly repeated expenses. So for example, monthly cell phone bills would be a monthly uh, repeated expense, or also intelligently route expenses to the appropriate approver based on claim amounts. An example of the expenses agent scenario is shown in this diagram. And the diagram shows first the user asks the expense agent a question about expenses that can be claimed. Then the expense agent can accept the question as a prompt. Then the third is the agent uses a knowledge store containing expenses policy information to ground the prompt. And then the grounded prompt is submitted to the agent's language model to generate a response. And finally, the agent generates an expense an expense claim on behalf of the user and submits it to be processed and generate a check payment. Also, in more complex scenarios, organizations can develop multi-agent solutions in which multiple agents coordinate work between them. So, for example, a travel booking agent could book flights and hotels for employees and then automatically submit expenses claims with appropriate receipts to the expenses agent. So we have several options for agent development. There are many tools and many frameworks available to help developers create AI agents, and some are designed for professional developers, while others are great for business users with little or no coding experience. So let's break down the main options here. We can start with Azure AI Foundry. Azure AI Foundry has an agent service. This is fully managed service in Azure. It is built on OpenAI Assistance API, but with a lot more flexibility. So you can choose different models, connect to your own data, and apply enterprise-grade security. Also, it supports both OpenAI SDK and Azure Foundry SDK. This one is best for developers building secure, scalable agents in Azure. Second one, we have OpenAI Assistance API. This is a simpler version of the Foundry agent service, and it works only with OpenAI models. It can be used in Azure, but has fewer features than Foundry. So this one is best for quick prototyping with OpenAI models. Then third one, we have Semantic Kernel. This is an open source toolkit for building AI agents. This one is great for creating multi-agent systems where different agents can work together. It is lightweight and flexible. And this one, it is best for developers who want full control and customization. Fourth one, we have AutoGen. This is another open source framework. It's ideal for experiments and research and helps you build agents quickly and test new ideas. So this one's best for rapid prototyping and innovation. We have Microsoft 365 Agents SDK. So this one lets you build agents that work across platforms like Teams, Slack, or Messenger. And despite the name is not limited to Microsoft 365, this one it is best for developers creating agents for communication platforms. Number six, we have Microsoft Copilot Studio. This is a low-code tool with visual interface. It's designed for business users, so people who aren't professional coders. Easily integrates with Microsoft 365 and other common goods. So business users who want to build agents without writing code can use this tool. And finally, we have Copilot Studio Agent Builder in Microsoft 365. This is a declarative tool where you can describe what you want, and it builds the agent for you. So this one's great for creating simple task-focused agents. This one is best for business users that want to automate everyday tasks. Let's see if I have a couple minutes. Maybe I can show quickly the AI agent. So I talk about Azure AI Foundry agents. So in Azure AI Foundry agents, you can easily create a, oh, there it is, there's my screen. You can easily create an agent in the portal. You would just go to Azure AI Foundry, you can go to agents, and you can hit create a new agent. Once you hit create a new agent, it will give you the option to deploy with a model. So in this model, I already have a pre-created expenses agent, but we can take a look at this one. You would select the model that you want to use. In this case, I'm using GPT-4o. The name of my agent is expenses agent, and I'm using a knowledge. So once you're creating your agent, it will give you the option for knowledge. What knowledge is basically the data that you want to use for your agent to be able to provide answers based on that data that you provided. So in this case, I already added a Word document that includes several information, includes all this information about expenses, so what can be covered and what not. So for example, for this meals, we know that it only covers $50 per day. So if I want to try my agent here, I already have this agent created. So ask my agent, let's see, what can we ask my agent? Here, what's the maximum I can claim for meals? The response should be $50. So you can try that out. So there it is. The response maximum you can claim for meals is when I created the agent, which is down here. Okay, now I'm going to go back to the presentation. Okay. All right. So with that, we conclude this presentation for generative AI. A way that you can continue learning here, you can visit us at aka.ms/woman in Azure AI /start-here, or you can scan the QR code. Oops, sorry. Here's the contact information. Coworker Joanna, she was first speaker. Feel free to add us on LinkedIn. My name is Danielle Rodriguez. My LinkedIn is on there too. We have moderators Bobby, Jacqueline, and Gabriela. In our next session, we have a next section for tomorrow. This is an extra session that will be leading the age of AI, people growth and generative intelligence. So thank you very much.